Alright, in this video we're going to talk about section 5.4 part 2, dividing polynomials. So first we will review long division and then spend most of our time learning a new method of division, synthetic division. And we'll talk about the remainder theorem and then some different applications of this type of division. We can use it to factor polynomials, evaluate them for different values, and then find remainders. So first of all, here's a polynomial long division problem, and I thought it might be helpful to just go over this again and review how we would do this, and then we'll compare doing the same problem but with a different method. Okay, so you might recall that we check the first two terms here, all right, the first one of each of these expressions, and we ask x times what equals x cubed. And that goes up top here, that's x squared. Alright, and then multiply x squared times each of these terms, x and x plus 2. Okay, and then that goes underneath. So x squared times x is x cubed. X squared times 2 is plus 2x squared. And then we subtract. So x cubed minus x cubed is 0. And we talked about the fact that we can stop writing the zeros now. Okay, so leave that blank. And then negative 14x squared minus 2x squared is negative 16x squared. And then once you've done that, bring down the next term, plus 51x. And repeat this process. So then we look at the first two terms again, the x and the negative 16. X squared, alright, and x times what makes negative 16x squared? Well, we need a minus 16 and also an x. And then go back and multiply, so negative 16x times x plus 2. So that would give negative 16x squared, and then negative 16x times 2 is minus 32x. And subtract. Alright, so the first terms cancel, that's 0. Then 51 minus a negative 32 is 51 plus 32, that's 83x. Alright, and then carry down the negative 54. And then x times what is 83x. Okay, so we need a plus 83. And then that gives 83x. Okay, and then 83 times 2 is positive 166. And then subtract. Alright, so we get 0. And then negative 54 minus 166 is negative, let's see, that's 220, I believe. Yes, 220. Okay, so this one doesn't divide evenly, this has a remainder. And then we also talked about just expressing the answer as a polynomial. Alright, so now we can say that, actually, I'll do this on a new page. Alright, so now we can say that the original polynomial equals the thing that it was divided by and the thing that we just found multiplied together. Okay, so x plus 2 times x squared minus 16x plus 83. Alright, and then there's also that remainder, so we need to add on whatever's left. In this case it's a negative 220, so I could actually just subtract instead, negative 220. Alright, so this is similar to what we did with looking at like a division like 7 divided by 3. Alright, and we said that, you know, when you go through the long division process here, okay, you stop when this number is less than the thing you're dividing by, and then that's going to be a remainder. So we can write 7 divided by 3 is 3 times 2 plus the remainder plus 1. Okay. The other thing we talked about was knowing when to stop this long division process, and it's when this remainder has a degree that's less than the degree of the thing you're dividing by. Okay, so we couldn't stop. This has a degree of 1, x to the first power, so we couldn't stop until we got down to something with degree 0, or just a constant number. All right, so let's compare. We know that this division, basically, here's our answer. Okay, we're going to get this polynomial when we divide and then a remainder. So let's try the same problem using a different method, and then we have an answer to compare it to. All right, so here it is, and this is the first problem we will do using synthetic division. It's called synthetic because it's kind of think of fake or man-made type of a process. So it looks a little different than division. It's more of like a quick algorithm or a shortcut, but it accomplishes the same thing. All right, so what you want to do is work only with the coefficients. We're not going to actually work with any of the variables until the end. So first you look at the thing that you're dividing by, and this is a factor, all right, or I guess we could say this is like an algebraic expression. And what we want to do is find the 0 that's associated with that expression. All right, so in other words, if you set that equal to 0 and solved for x, what would you get? All right, so -2 is, if this was a factor, this would be the 0 associated with that factor. So once we have that, we're going to write it in a little box on the left-hand side. Okay, -2, and then a little box. All right, now next to it, we're going to write all of the coefficients of this polynomial and fill in any zeros if there were any missing terms. All right, so my terms are degree 3, degree 2, degree 1, and then degree 0, so I don't have any missing numbers. All right, so I just fill in the numbers that I do have. All right, so this is a 1x cubed, -14x squared, 51x, and -54 for the constant. Okay, I'm going to be filling in some numbers right below it, so I'm going to leave a space and then draw a line. Okay, so to start off the process, you carry down whatever the first coefficient is to below the line, right? And then you're going to multiply 1 times -2 and put that number here. All right, and then carry these down by adding. So -14 plus -2 is -16. And then we repeat. -16 times -2 is +32, and that gets written here. And then you carry these numbers down by adding, so that's 83. Okay. Then multiply 83 times -2, and that's -166. And then carry these down by adding, and that's -220. All right, so those numbers should look a little bit familiar. They're the ones that we got when we did this using polynomial long division. All right, now these are just the coefficients, so what we need to do is go back and put the variables next to each one to construct a polynomial. Well, how do we know what the variables are? We just look at what we started with. We started with a cubic, and then we divided by something linear. All right, so think about if you just had x cubed divided by x, that's going to give you x squared. Right. So basically we're just dropping down 1 degree when we divide. All right, so I would fill in this new answer is going to be an x squared, and then I just go down in degree for each term. So this is x squared, so then this would be an x. This would be the constant, and then this is going to be the remainder. All right, so the answer to this division problem is x squared minus 16x plus 83, and then we can write an R for remainder, -220. Okay, or another way of writing it is the same as we did in the previous problem. All right, I could write this and show kind of like a complete factorization. Okay, let's try another one. So here's the polynomial, and we're dividing it by x minus 7. All right, so first of all, what's the 0 associated with this? All right, set it equal to 0, solve for x, and x equals 7. And you may start to notice the pattern. The answer, the 0 here, is always just going to be the opposite, right, of whatever number you see here, unless, like, if there's a number in front of x, then maybe you'd want to set it equal to 0 to solve. All right, but in this case, it's just always going to be the opposite. All right, so now we need to set up all right, our synthetic division tool here. All right, so that 7 we found goes in a little box, and then we'll list out all the coefficients of the polynomial that we're trying to divide. So this time I have degree 3, a term with degree 1, and a term with degree 0. So I've skipped x squared, so this time I need to fill in a 0. All right, so we have 1 for x cubed, 0 for the x squared term, negative 57 for the x term, and then 56. Okay, draw a line, and to start off, bring down the 1. Okay, then 1 times 7 goes here. Okay. Add to get 7. Then 7 times 7 is 49. Okay, negative 57 plus 49 is negative 8. Right? And then negative 8 times 7 is negative 56. And then adding 56 plus negative 56 is 0. Okay, so now we need to fill in the variables. So we had x cubed divided by an x polynomial, so this is going to be x squared, x, and a constant. All right, so the answer is x squared, and then we need plus or minus signs, so the ones that are negative already have that the minus sign with the number, but for this 7x, if there is no sign there, that's a positive number, so you put in a plus sign. All right, and this one has no remainder, so you can write remainder 0, right, or you can just write nothing, and that would be correct as well. All right, so this polynomial divided by x minus 7 equals x squared plus 7x minus 8. All right, so if you're thinking that this is a little bit easier than long division, you might be wondering, why don't we just use this all the time? Well, the answer is that synthetic division only works when you're dividing by linear terms. Okay, only works when dividing by linear terms, or things that look like ax minus b. All right, so if I'm dividing by 2x minus 3, I can do that by synthetic division. I can do things like x plus 5. All right, I can't do things like x squared plus 4. Okay, or x cubed minus 1. All right, so that's why we still learn long division. It is necessary in many cases. All right, here's a problem that we can solve using synthetic division. This is problem 4 from the section in your textbook. We have a shadow box, and we're told that the polynomial x cubed plus 7x squared minus 38x minus 240 expresses the volume in cubic inches of the box. And then if you look at the picture, they give you another polynomial that describes the width, x plus 5. And what we need to do is break down the volume of the box, this polynomial, and use it to write the box's dimensions. All right, so we need to know that volume for a 3D box shape like this is length times width times height. So since we have a polynomial, we're just going to get the polynomial equals 3 other polynomials all multiplied together. So that's the goal. All right, well, how are we going to do this? Basically, we're going to divide, because we know, for instance, if I took the volume and divided by the width, okay, what I'm left with is just length times height. All right, so if I take this polynomial and divide by the polynomial that represents the width, then I can break this down a little bit and get an expression that represents length times height. So I'd be one step closer to finding the dimensions for the box. All right, so let's try it out. And x plus 5 is a linear factor, so I can use synthetic division. So let's do that. All right, so the 0 that goes with this is -5. And then I read out the coefficients for this volume polynomial. So x cubed, that's a 1. X squared is a 7. The x term has a -38. And then I have a constant of -240. Okay, let me slide those over. Okay, so carry down the 1. 1 times -5 is -5. Then add, and that's 2. 2 times -5 is -10. And if I'm adding negatives, it's going to be a negative answer. And 38 and 10 is 48. 48 times 5 is a negative times negative, so that's positive. And that's going to be 240. And then adding, we get 0. So this one works out nicely. It divides with no remainder. And the expression that's left, all right, we had a cubic divided by an x again, so this is going to be an x squared and an x. So now I'm left with x squared plus 2x minus 48. All right, so right now what I have is that the original polynomial, x cubed plus 7x squared minus 38x minus 240 can be broken down into the factor that we were given, x plus 5, and the new quadratic that I just found, x squared plus 2x minus 48, and no remainder. All right, so this one represents the width, and then this represents length times height. So what I want to do now is try to factor this to see what those expressions are. So you can take your pick. You can try to factor using that the AC method, the x method, or you could use the quadratic formula if you like. And I think I'll try the factoring method for this one. Okay. So we have -48, and the middle term is a 2. Okay, so I need two things that multiply to be -48, so I need a positive and a negative. Okay, that give 2. And eventually you'll land on 8 and -6. Okay, now this has a 1 in front of the x squared, so I can just shortcut and go directly to the answer. So this is going to factor as x plus 8 and x minus 6. Okay, so the dimensions of the box, to finally answer their question, the dimensions would be, now remember we usually give dimensions as like something by something by something. All right, so like we could have like a box that's 2 by 3 by 8 or something like that. Right. So here we could say like x plus 5 by x plus 8 by x plus, or x minus 6. All right, or we could also just label everything. So I could say like width equals x plus 5. Okay, now how do I know which of these is the length and which is the height? I'm thinking of height as like the depth of the box, so that's probably going to be the smaller number, at least based on their picture. So x minus 6 is going to be smaller than x plus 8. Okay, you can plug in a few numbers if you wanted to test that. So I'm going to assume that the length is x plus 8 and the height is x minus 6. All right, so a couple different ways to give your answer. All right, here's another one. If the polynomial x cubed plus x squared, 6x squared plus 11x plus 6 expresses the volume in cubic inches of a box and the width is x plus 1, what are the dimensions of the box? So I'll try synthetic division again. The 0 that gets associated with x plus 1 is -1. Okay, and then I have x cubed, x squared, x, and a constant, so no missing terms. So I can just fill in those coefficients. So that would be a 1, a 6, an 11, and a 6. and then divide. Okay, so carry down the 1. 1 times negative 1 is negative 1. Add 6 minus 1, that's 5. 5 times negative 1 is negative 5. 11 minus 5 is 6. 6 times negative 1 is negative 6. And then 6 minus 6 is 0. Okay, so I've got, this is x squared plus 5x plus 6. Right. And then I can break that down either by factoring or the quadratic formula. So this looks pretty easy to factor again, so I'll try that. So we have a 6 and a 5, and looks like 1 and 5 are going to work. So this is x plus 1, and let's see. Oh, nope, that's not right. Okay. Okay, so I actually want 2 and 3. Okay, 2 times 3 is 6, 2 plus 3 is 5. So x plus 2, x plus 3. Alright, so the dimensions of the box, we had 1 we already knew, x plus 1. Okay, x plus 2 and x plus 3. Alright, here is a very important theorem. It's called the remainder theorem, and this describes the connections between dividing a polynomial and finding its remainder and evaluating a polynomial for a certain value. Alright, so here's an example, and basically what we're saying here is when you divide by x minus some number, the remainder is the same as whatever you would get if you just plugged that number into the function and evaluated. Alright, so let's check this out. So here's a polynomial. P of x is x to the 5th minus 8x cubed minus x squared plus 2. Alright, so first, if we wanted to find p of 3, okay, so the option that you already know for how to find this is to plug 3 in every time you have an x, and then evaluate the polynomial. So 3 cubed minus 3 squared, oops, plus 2. Alright, and let's check this one real quick just so we have an answer to compare. Alright, so 3 to the 5th is 243. Okay, 3 cubed is 27, and 27 times 8 is 216. Okay, 3 squared is 9, so minus 9 plus 2. And then when we subtract, we get, let's see, 248 minus 216 is 32, I believe. Yeah, 32. Okay, minus 9 plus 2. Okay, so that would be 23 plus 2, and that's 25. Alright, so P of 3 is 25. Alright, so remember that number. And then we're going to try this using the synthetic division method. And this is the other half of what the remainder theorem is telling us we can do. Alright, so we will try, we'll try dividing this polynomial by x minus 3. So it's x minus whatever this number in parentheses is. Alright, so that means that the 0 that goes with that is just going to be this number, 3. So that's what I use for synthetic division. Okay, and then the coefficients, I have an x to the 5th term. I'm missing x to the 4th, so fill in a 0. Then negative 8 for the x cubed term, negative 1 for the x squared term, and then 2 for the constant. Okay, so carry down the 1. 1 times 3 is 3. 3 and 0 is 3. 3 times 3 is 9. Negative 8 plus 9 is 9 minus 8, so that's 1. 1 times 3 is 3. Okay, oh, I'm missing a number, aren't I? Let me back up for a minute here. Okay, we were missing an x term as well, so I should squeeze a 0 in here. Okay, and then the 2. Okay, that should do it. So 3 minus 1 is 2. 2 times 3 is 6. 0 and 6 is 6. 6 times 3 is 18, and 18 and 2 is 20. And let me think for a minute. I think I have a mistake in here somewhere. All right, I suspect the mistake is in evaluating. I'm wondering if when we plug 3 in, if it's not really 25. So let's double check that. Okay, I'm going to use a calculator, so check if you want to what you get for this when you plug in a 3 into that polynomial. All right, and sure enough, when I plug in 3, I used a calculator this time. I was trying to do too much in my head. I am getting 20 as an answer. All right. So here's what this theorem is saying. All right, when you plug in 3 and evaluate it using order of operations, you should get the same answer as the remainder when you do synthetic division. All right, so I actually kind of like this method, synthetic division, and you can see, it was easier to make a mistake when I did that the first time because the numbers got so large, but in this case it kept the numbers a lot smaller to use synthetic division. Right? And as an added benefit, we actually were able to factor this polynomial as well. So we weren't asked to do this, but this is essentially like dividing by x minus 3. Right? So I could go on and fill in these variables. This is x to the 5th divided by x, so this is going to be a quartic, right, x to the 4th, plus 3x cubed plus x squared, right, plus 2x plus 6 with a remainder of 20. All right, going the other way, right, the theorem also tells us that we can check if something is a factor by substituting in the 0 that's associated with it. All right, so if I wanted to check this polynomial, p of x equals x squared minus 4x plus 3, and if I wanted to see if x minus 1 is a factor, I have two options. So option 1, right, I would plug in, all right, the 0 associated with it, the 1, and see what I get. Okay, so that's going to be 1 minus 4 plus 3, that's negative 3 plus 3, which is 0. And then the remainder theorem tells me that this number is the remainder when dividing this polynomial by x minus 1. So if I get a remainder of 0 when I'm dividing, that means that this divides in evenly, which means that it is a factor. Okay, so yes, x minus 1 is a factor. All right. How about x plus 3? Well, I could do the same thing. All right, I can plug in 3 here. 3 squared minus 4 times 3 plus 3. And get 9 minus 12 plus 3. All right. Oh, sorry. Hang on a second. Should be plugging in a negative 3. Okay, because the 0 that goes with x plus 3 is a negative 3. So that would be negative 3 squared minus 4 times negative 3 plus 3. Okay, so that would be 9 plus 12 plus 3, and without even calculating what that is, I know for sure that that's not 0, so therefore no, x plus 3 is not a factor. All right, I can check either of these using synthetic division, and in your homework you're specifically going to be asked to use synthetic division to decide these questions. All right, so doing it that way, you would test 1. All right, if you're testing is x minus 1 a factor. Okay, so the coefficients for x squared minus 4x plus 3 are 1, negative 4, and 3. And then use synthetic division. Okay, and there's the remainder of 0. So yes, this did divide evenly. Okay, checking negative 3 with synthetic division gives, let's see, negative 7, 21, 24, and then this number is not 0, okay, so no, that one doesn't divide evenly. It's not a factor. Okay, and then we'll try one last problem. Factor y equals x cubed minus 4x squared minus 9x plus 36, given that x plus 3 is a factor. All right, so in the next section we'll talk about how to do this without knowing any of the factors. But here, if you're given one, that gives you a starting place. And since this is a linear factor, we can go ahead and use synthetic division. Okay, so I would use the 0 associated with that factor, which is -3. Okay, and then use the coefficients for this polynomial, which would be 1, -4, -9, and 36. Okay, I wasn't missing any terms. X cubed, x squared, x, and a constant. Okay, so one more time, try this synthetic division. Oops. Okay, and since we know that this is a factor, then you should definitely see a 0 here at the end. If you don't, then there's a mistake in your arithmetic. All right, now we want to keep on going. So what I have now, this is a cubic divided by a linear term, so this is now a quadratic. All right, so now I'm down to x squared minus 7x plus 12. And then your choice, either quadratic formula or factoring, to try to figure out the other two factors. So I will try factoring, see if that works. So we have 12 and -7. And it looks like -4 and -3 will work. So this is going to factor as x minus 3 and x minus 4. Right. Now this one said to factor it completely. So this one, this problem does want you to write your answer in a very specific way. And we want to write this as y equals, okay, and then we're just going to break this polynomial down into its complete factorization. All right, so we have two of them, x minus 3 and x minus 4, and then we also have the other one that we were given at the beginning, the x plus 3. All right, so this would be how you would write your final answer. All right, here's your homework. This is page 325, numbers 7 through 27 odd. All right, the first ones ask you to divide using synthetic division. All right, so you can kind of just give your answer as a polynomial if you'd like. All right, so for example, for number 7, it's an x cubed divided by an x. So your answer is going to be something like x squared dot 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 dot. Okay, number at the end, and you can leave it like that. Okay. Number 13, use synthetic division and the given factor to completely factor the polynomial function. So that's just like the one we just did. So your answer is going to look like y equals something times something times something. Okay. 15 is a geometry one, using another volume of a box. Okay, finding the linear expressions with integer coefficients that represent the length and height of the box. So same thing, they just want you to factor. We know that the width, all right, is an x, right? So you're going to use synthetic division, and this one actually is a little bit different. All right, what do we do if we're dividing by x? All right, so to divide by x, what you want to do is think of this as dividing by x plus 0. So then 0 is the number that goes in the box for synthetic division. All right, so everything else is the same, but 0 is the number that goes there. Okay, 17 and 19, use synthetic division and the remainder theorem to find P of A. Okay, so for 17, you're trying to find P of 3. Okay, so they want you to use synthetic division with 3. Okay, and then look at the remainder, and that's going to be your answer. All right, so like if you got a 7 as an answer, then we would know P of 3 equals 7. Okay, and then 21 and 23, determine whether the binomial is a factor of the given polynomial. So same thing, use synthetic division and see if you get a remainder of 0 or not. And then 25 and 27, we're back to dividing using synthetic division again. Right, in all of these, watch out for any missing terms that you would need to fill in with zeros. Okay, so when you're writing your coefficients across the top, maybe it's like 1, 2, 7, etc., 5. If there's a missing term, then remember to fill in a 0. Okay, I hope those hints are helpful to get you started on your homework, and let me know if you have questions. All right, thanks.